Andrew Josephson. I'm Joseph Aiello.
And I'm Anthony Grassi.
And our senior project is the multi-biosensor for grape clusters.
The Penn State Lake Erie Regional Grape Research and Extension Center needs a digital system to aid in measuring the effectiveness of the herbicides and other treatments used on their wine varieties of grapes. Our system will be the first of its kind, providing measurements via physical probes inside the cluster. The LRGREC team has published research showing just how tight specific varieties can be and how this compactness affects the treatments of the cluster.
The hardware design is one of the most important factors for our project. In order to measure the parameters that the Lake Erie Regional Grape Research and Extension Center is looking for, we need to find sensors that were small enough to fit in the grape clusters and be fully waterproof. We currently have 3 sensors. One measures the moisture content in contact with the sensor. The second can take temperature and relative humidity readings. And the third is a force-sensitive resistor that will be inserted into the cluster to take force readings. And along with the sensors, our system needs to last up to 4 months out in the vineyard. With how much current the system draws when running, we'll need a battery bank to provide the amount of power we're looking for. By using 8 3.6 volt lithium batteries, we can provide over 150,000 milliamp hours for the system. This can power it through the 4-month growing period and give us some overhead to perform tests and guarantee the minimum operating requirements.
To control the system, we used the Arduino Nano. We chose this board because it offered low power draw while still having enough I/O and processing power for our purposes. To lower the power draw even further, the microcontroller will enter a sleep mode that disables the main oscillator timer, SPI interface, I2C interface, and the ADC. In order to interrupt the sleep mode while the main oscillator is disabled, we can utilize the watchdog timer to create a 1-hour interrupt. The code will interrupt the sleep mode hourly to take 100 readings, average them, and then store the results to the micro SD card.
With the system put together and operating within our design constraints, it will last all 4 months while staying completely dry and provide valuable information to the LRGREC team.